welcome to the third episode of the Coordinated. Like as you guys saw, okay, I announced the EigenLayer Focus podcast just a week back, and now we are with Lagrange founder Ismael. And thanks for first of all providing the space. It looks nice. Looks like we are doing a real podcast here. And thanks for coming in.
Thank you so much for having me. I have to know, who were the first two guests?
So the first was from EigenLayer, Matt, who is leading the EigenLayer part.
Oh, I love him.
And second is EigenLayer founder, YQ.
One of my best friends. We're doing a podcast with him this week too.
Yeah. He was
You have the best taste in who to bring on.
Yeah. I think Alton helped a lot to coordinate with all the guys, selecting the guests, and I was first to reach out to him.
Yeah.
Hey, I want to do this. Can you help me? Okay, fine, sure.
Yeah.
And I think he just coordinated with lots of folks. Helped me also in touch with the EigenLayer core folks.
Yeah.
And probably I'll do one episode with Nader also if he manages to crunch some time. So coming to you basically.
Yeah.
So I know you have a short time and all. I'll just crunch. I have a lot of questions, but I'll squeeze it as much as possible. So I think you have a pretty interesting background, from being an entrepreneur, then also you have a stint with VCs.
Yeah.
And as your Twitter bio mentions, you're an engineer at heart.
Yeah.
So just want to know how these three things stitches together because they are very different in their own nature.
Yeah.
And what led you to crypto?
Yeah.
All these three things.
So when I was in university, I studied computer science. And I did a lot of internships involving emerging technology, AI, crypto, and I was trying to find my footing of where I kind of wanted to work in the space. And when I started my career, I was working for a large TradFi company, an insurance company called Manulife in Canada, John Hancock in the US. And, at the time, it was early in the first DeFi summer. There was a lot of great innovation being done with kind of on-chain financial primitives, and the TradFi company I worked for wanted to try to get into the space. And so they were trying to spin up a crypto practice, and unfortunately, no one there really had a familiarity with kind of building smart contracts, deploying anything on-chain, or really understanding how on-chain products could even be built. And so, it was my first job out of college, and I kind of had experimented with this stuff in college before, and I said, hey, I'll do it. And over the course of a couple of years, I built out an engineering team there, and I built out kind of the crypto practice. But unfortunately, anything that is done in TradFi, there's large compliance requirements for doing anything in a decentralized and permissionless financial ecosystem. And so unfortunately, couldn't have ever brought these things to market. And so there's nothing more disappointing as an engineer than spending all this time building something and not being able to see it realized in the world. And so I left, and I actually went into Web 2 to kind of work as an investor, which I felt was kind of close to the cutting edge of innovation, to deploy resources into early stage founders, building awesome stuff, and to be hopefully a thought partner as they scaled. But I was working in Web 2. We're investing in kind of the things that at that time, around COVID, that Web 2 investors invested in, which was, fintech rails, B2B SaaS, future of work, consumer payments. And a lot of this stuff was 200x forward revenue multiples on software. Wasn't very durable, and it didn't feel very impactful. And then as I saw the crypto market start to inflect again, and this was, pre-FTX, I said to myself, look, I see a lot of these stuff that I built actually now materialized in production by someone else other than me, that I never was able to launch it. Someone else took the opportunity to launch this stuff. There was the Nexus Mutuals of the world, the Ambulance of the world. And I said, you know what? I'm always going to regret never having taken that step to build my own thing if all I do here is sit and deploy into founders chasing their dreams. And so I left, and I said, I'm going to, found Lagrange. And the first 6 months, a year were rough, right? Nobody wanted to invest early on. ZK wasn't as exciting as it is now. And, I fortunately was able to build a great team and find great backers across 2 rounds who believed in our vision. And we've been able to materialize a lot of really interesting products into market. And what's exciting to us is now I feel like there is this kind of collection of people around EigenLayer, around restaking, around ZK, who all share the same kind of cypherpunk futuristic vision that drew me to the space in the first place.
Nice. I think we all know, right? It's a financial space, crypto and all. But what you just mentioned, I think that has a sort of an impact and like do something more than a
Yes.
transaction-based thing. Because as you was mentioning throughout, you want to like go get there, showcase yourself out of them in the market and like do things. I think like great start. I think nice for mentioning.
Yeah.
Great to mention all these things. I think moving on to the next part is I was just when I was researching about this podcast and was
Yeah.
seeing a few things. I think roll up ko guys keep mentioning ki yeah you are a ZK bro, and like and just want to know
Very
like
kind of them.
how is the like how you because there's so many things are going right,
Mhm.
like what brought you into ZK, and like the I
Yeah.
think most of what Lagrange does is very closely associated with ZK stuff.
It is.
Want to know like how that your affinity towards ZK like helped the foundation of like Lagrange.
Yeah. So what I love about ZK is that it's unambiguously the directionally correct technology. The entire world that we interact in is based on trust. The trust in a financial institution, the trust on the internet in a certificate issuer, the trust in the ability of the apps you use to correctly route you to the right places, to custody your information properly, to custody your assets properly, to custody your data properly. What crypto is a substrate to remove the need for trust in centralized authorities. Blockchains remove the need for trust in centralized asset issuers, and wallets remove the need for trust in centralized custodians. What they limit or are limited by is expressivity. What you can build on a blockchain is limited compared to what you can build in a Web 2 system. ZK is the way to self-custody your information and to build expressive apps that can be succinctly verified in hubs of decentralized trust like Ethereum. And so what drew me to ZK originally was working at a large insurance company, trying to build interesting products that retain data privacy. If you want to build an on-chain insurance protocol for an off-chain life insurance policy, you need to bridge between Web 2 and Web 3, and you need to move confidential information in a way that doesn't risk plan participants. That requires ZK. And more broadly speaking, if I want to build anything on chain that can't be written in a simple contract and solidity like a DEX or a over-collateralized lending app, something in there will need ZK. I'll need scalable, verifiable execution of a blockchain like a rollup or an L2 that is proven in ZK. I'll need to extend the execution of my smart contract sitting on a chain with a coprocessor in ZK. I'll need to access exogenous off-chain data in ZK with ZK-TLS. And I'll need to bridge between these execution spaces with verifiable interoperability with ZK. And so the only way for us to kind of realize this futuristic vision of a decentralized and equitably accessible internet is through verifiability of all of these things that can't just be encoded in a simple state machine.
Cool. I think that gives the foundation of like help me pick your brain ki why you were into ZK and what like kind of inspired you to come into like build Lagrange. I think quickly we'll like ask the main like we'll go to the main ethos of what the podcast is about EigenLayer.
Yeah.
I think my key question is what like inspired you or what pushed you to build the Lagrange thing on EigenLayer?
Beyond all my conversations about internets of verifiability, and beyond the extent that I think, Sriram is one of the most people I look up to ideologically in the space, the most intellectually honest and really forward-looking operators I see in crypto. From a purely practical standpoint, EigenLayer is a fantastic product. What it offers is a capital efficiency that you find nowhere else in crypto. So we have this ideological affinity for what EigenLayer is building, and then a strong practical root of why I think their technology is so impactful. And when I look at restaked assets very broadly, the cost of capital of using those in a system is substantially lower than alternative assets that you would use. So if I was to launch a chain in the Cosmos, a POS chain, let's say, what I'd have to pay for security is 15 to 25% plus per year in emissions. Very expensive, dilutes tokens, and creates these down-only trajectories of POS systems. EigenLayer, because you have the native yield from Ethereum, you don't have to subsidize that with an emission. what you can do is pay the marginal cost of the risk that's introduced by the marginal system. And that is, if there's no slashing, 10 to 15 basis points per year, maybe even less, maybe more, depending on the risk you introduce. And that's something that's fundamentally unique. There's no other place in crypto where you can build an app with that low capital cost. And if you ask yourself, what does low capital cost let me build? Well, very simply, it lets you build systems that have high costs other places that can be subsidized, that can be used without creating an overall untenable design. So a ZK system has a very high operating cost. To run a prover is expensive. And if I need to have you stake an expensive asset to guarantee liveness on your expensive prover, it's just not feasible. So if your operating costs are tens of thousands of dollars a month, your capital costs can't be 20, 30% of the stake. And so this is why I think a lot of the most forward-looking technologies that are by definition expensive, DPIN, ZK, AI, FHE, are gravitating towards EigenLayer.
Nice. I think this give us the two things. One is obviously why Lagrange kind of chose EigenLayer as one of their main platforms to build upon. And I think that also gave us an insight ki what are the possibilities of EigenLayer at a very at an overview level. I want to dig deeper into it, but I think we have a crunch in time and we will quickly go towards Lagrange based things. Like we know there are two AVSs which are live currently in EigenLayer. I think the ZK proven network, which when I was talking with you and you were very optimistic towards that and you want to take that to the next level. So if you can just give us a 101 of what is ZK proven network, basically starting giving a brief overview of proven network and how the ZK proven network of Lagrange using EigenLayer is coming into the picture.
Yeah. So at the core, what Lagrange is building is the centralized economy of proving. There are so many places in crypto, ranging from ZK-TLS, the coprocessors, to validity proofs for rollups, even to verifiable ML models that over the next 5 years, the next decade, will need the generation of proofs. And what Lagrange is fundamentally is a network of networks. It's a prover network of prover networks of prover networks. And it creates these markets that can be easily instantiated for any arbitrary proof type and have sovereignty and agency over the generation of that proof type within this broader ecosystem of proving. And you can have these markets for, a ZK-TLS protocol like opacity. You can have them for a rollup protocol like any of the top providers. You can have them for our coprocessor product, which is in production right now. You can have them for the state committees and state proofs that are in production right now. It's effectively this network of networks doing proving. And that is what we believe is this foundational substrate for building what I like to call the verifiable internet, right? The thing that will take blockchains from being these limited execution state machines to this unbounded amount of computation. And that's something that I think is woven into the fabric of what the space will become. And so on EigenLayer, this is a production network that's live now that's generating proofs for our coprocessor product, which is integrated with a bunch of DeFi protocols and NFT protocols, people like Gearbox, people like EtherFi, as well as NFT protocols, Azuki, and a bunch more to announce soon. And it's delivering proofs in production today, letting them do things that would otherwise not be possible without ZK. And the second part is interoperability proofs. This is what our state committees and state proofs power. And these are integrated with Polymer, Axelar, Layer 0, and a bunch of the top interoperability providers who understand that verifiability is the core to their business's evolution over time. As ZK costs get cheaper, very few people would say, no, I don't want a proof.
Cool. I think that's a pretty crunched down overview of the thing. I think sometime later when this DevCon things are over, we'll have an episode where we'll just go deep into all this.
Yeah.
But before that, let's quickly go to the next part of that is the ZK Coprocessor of Lagrange, which is I think another thing you are very very vocal about. I've seen you tweeting about it, and whenever we had a discussion a little bit, and you just think, yeah, I want to take this to the way on beyond the Lagrange ZK processor. So before as we did with the last part also, if you can give us a short overview of what are coprocessors and ZK coprocessors and how Lagrange ZK coprocessors are is coming into the picture there?
Yeah, so our ZK coprocessor is a fundamental prover that Lagrange builds that was developed in-house that allows us to prove SQL-based computation over blockchain data. Think about it like Dune analytics, but verifiable. Instead of you consuming that data off-chain in a dashboard, your contract can read it, interpret it, and use it for core business functions. And this is something that we think is this next step to evolve DeFi and evolve really what it is to build on-chain applications. So if you want to build a yield-bearing token today, you'd have to accumulate state over how long a user held an asset. You'd have to determine whether or not that asset has been, what percentage of the total supply is made up, and determine the reward rate per block. And there's a lot of computation you'll have to do in your contract. And because of that, over a range of blocks, you can't do it really in Solidity. What you have to do is find a way to find some approximation of it. And this creates these like inefficient standards, like the Sushi Master Chef contract or the 1-inch farming pool contract that really need an evolution. A next way it can be done that is more secure and more expressive. And so we were working with protocols like Gearbox on this to really define new standards for DeFi on-chain that uses ZK. And then also, we can talk about the work that we do with EtherFi, a protocol I'm sure you're familiar with. That's an LRT on EigenLayer that does verifiability over how they do cashback for their credit card. Right, you have an on-chain credit card. Right, if we're moving the whole banking system on-chain, we're going to need credit cards that people can use. And would you use a credit card without cashback?
Obviously, no.
Probably.
Yeah.
Right, and so it means that if we're moving the credit cards on-chain, we got to move the cashback on-chain, got to move the points on-chain, and all of that requires computational primitives that are not available currently.
Cool. I think if you can just quickly in a line or in less than a minute, if you can say how this coprocessor thing is using the EigenLayer stack, basically.
So it sits on top of our prover network. And our prover network is built on EigenLayer. So the way the prover network works is you need nodes that are bound and have an economic stake to ensure that they deliver proofs on time. What ZK is great at is saying, this is the answer and here's the proof. What ZK can't do is say, when you request that answer and that proof, the network will give it to you. That's the concept of liveness. And if the whole world is building for this future state with this decentralized financial system, we need both safety and liveness. Right? If someone can censor you, we haven't really built this equitable and universal financial layer. And so what our network allows you to do is to have these, these sub-networks that are each restaked on EigenLayer with different sets of assets that are able to deliver proofs with high guarantees of liveness. If you don't deliver your proof on time, you get slashed.
Cool. I think that gives us a quick overview of how coprocessor uses EigenLayer. Like, what are the applications which are currently built on the Lagrange's coprocessor?
Yeah. So I mentioned a minute ago Gearbox with the yield-bearing tokens. I mentioned EtherFi that uses the cashback. And I can also mention a few others. So one of them that I'm very excited about is liquidity incentives. There's some folks like Sappy Seals, like Beefy that are very interested that we've spent time with over liquidity incentives and how you want to develop kind of these on-chain designs for having people LP into a protocol and receive rewards for it. Royco is a team that we've actually very publicly discussed this with in the past, who is very bullish on ZK coprocessing as a primitive as well. Jai being a kind of an OG, a young OG DeFi builder. And also, like on a more kind of fun and experimental note, NFT protocols. I mentioned Sappy, but Azuki is one we've announced some very big work with as well over how they want to build collectors programs on chain. Things that are kind of using ZK to let you have badges and rewards in an ecosystem that has personalization. We did a podcast with Liz, I think we did multiple podcasts with Liz where we've talked about this idea of having these on-chain experiences that are kind of tailored to you, right? A consumer app personalizes in Web 2, right? Every app you log into in Web 2 says, hey, you're back. Here's what you've done last time. I'm aware of what you've done last time, and I'm going to tailor the experience next time for you. It's hard to do that on chain. Applications on chain can't personalize because they don't know the historical data. They don't know what you've done. They don't know what anyone else has done. ZK coprocessing lets you access that and build these interesting on-chain experiences for it. Azuki's on the forefront. We actually did a podcast with Luca from Pudgy, and we talked about this together as well. And there's some great, I think, consumer-facing founders who are understanding that this is the next step for crypto to be personal and to kind of be something that resonates with users.
I think like these are the pretty like new use cases which like I think I haven't heard. I think many people who are listening this or in Twitter also haven't talked much about it. I think we need a separate episode of how, let's say, Azuki is using Lagrange, or in the morning tweet I also saw you tweeted keep Nuffle Labs is also planning to use Lagrange in the backend.
Altan is a great friend of mine. I absolutely love Altan. He's one of the founders in the space who like I would always shoot more podcasts with.
Yeah, so I think this all needs a separate shows each. I think before wrapping up, just one last question is what's Lagrange end goal with EigenLayer? What you're seeing that?
What I want is for the entire crypto space to be built verifiably. I want every app to be a verifiable app. I want all the data they use to be verifiable. I want the execution to be proven. And I want users around the world to be able to access the same financial infrastructure. If you're in a country that has capital controls, you can't access USDC or stable currency, and the only store of value you have has 50% inflation per year, I want you to be able to access an alternative financial system that is equitable. And I want that to be driven by zero-knowledge proofs that allow you to retain sovereignty over your assets, sovereignty over your data, and security over the funds that you have in it. Self-custody, verifiability. And the thing with zero-knowledge is that if a single person is generating that proof of the application's next function, you can ensure that the users will be able to have the ability to withdraw their assets, receive yield on their assets, and participate in this infrastructure. You can have a single prover sitting on a satellite, and as long as it's generating proofs, you're fine. And so that is the future of zero knowledge, and I want every single of those proofs to be generated on Lagrange, and I want every single prover to be restaked on EigenLayer.
Cool. I think thanks for your time. I think this gives us a brief overview of what Lagrange is doing. I am sure I'll invite you again in some future shows, and we'll have deeper discussions.
I would love that. What would be a lot of fun is to come back on again soon with one of our partners, and we can present some new use cases that we're working on that are tactile with someone we're working with.
Sure. Thanks.
I would love that. Thank you so much for having me.
Thanks for coming.